Welcome back as we continue to find volumes by rotating solids around axes. Um, and now I think now that you're armed with two different methods, you've got the method of washers or discs, where you're basically looking at a cross-sectional area. You're taking a slice through the solid. You're saying the cross-sectional area is either a washer or a disc, or as I showed you, it could be a square or a triangle also. Or you could rotate it around and carve it up into little volumes of cylindrical shell. So when do you want to use one versus the other? Let's take a look at this. So the thing to remember then about washers is that you cut volumes perpendicular to the axis of rotation. Okay, so in this particular problem, this is my solid. My solid is defined by this, x equal to pi over 4, y equal to x squared, and I want to rotate about y-axis, or that would be x equal to 0. Okay, so you could do that. And what now? The thing to remember, you cut perpendicular. Okay, so I need to make my cuts. Then my cuts are like this. If I want to use the disc method, if I want to use the washer method, in this case, I've got to do what? I'm integrating a of y dy from 0, it looks like, to, what's this point right there? That point is pi over 4 squared. Okay. Is that the easy way to do it? Again, why am I looking at this? Because some problems, it's easy to use the washer method. It's hard to use the shell method. Some problems, it's easy to use the shell method, hard to use the washer method. But the thing to remember with washers, I've got to make perpendicular cuts. So here I need to have a of y dy. I'm going to now have to turn this into a function of x also. This is going to have to be x is equal to the square root of y. So I got a lot of work to do in this case. Look at what happens if I use shells, though. If I use the shell game, shells are parallel to the axis of rotation. Okay, this is pi over 4, I think. On the x-axis, right? That's the x value, pi over 4. In this case, the shell game's pretty simple. I didn't have to make the thing a function of x. In this case, I could write this down. This is just going to be 0 to pi over 4. Didn't have to find what the y value was. It's just going to be, what, 2 pi x times x squared dx. And that's not the greatest example, but again, washers, you cut volumes perpendicular. Shell game, you cut volumes parallel. You've got to understand, remember, you know what that shell is, right? That thing is rotating around here, giving me a cylindrical shell. There's my volume for the shell that I integrated. Let's look at another problem. So again, what makes a problem interesting, I just say find the volume. I don't tell you whether to use shells or washers. How about this one? Given a problem here, if I want to rotate it, here's my function. F of x is equal to x minus x squared. Now, I want to rotate this around the y-axis. What's my best bet here? Should I use again, you say, well, this is a shell right here. This would be to use shells. Or if I want to make cuts this way, this would be discs or washers. Which way is easier? Well, so you're going to decide if parallel or perpendicular volume cuts are easier. In this case, in order to use washers, I'd have to turn this into a function of y, which would be very difficult, okay? I could do it. Could do it both ways, but this is obviously setting my cut parallel. The parallel cut's going to be much easier. This is clearly a shell game here. And with the shell game, it's just going to be 2 pi x times what? X minus x squared dx from what? From 0, this is x equal to 0 here, to x equal to 1 there. Easy shell game. If you just had to, if you don't like the shell game, I've had students before, they just don't like it, they try to use everything in washers, you're going to get in trouble, because that's going to be a hard problem. Possible, but a difficult problem. Okay, and sometimes it'll be finding functions is easier. So what's maybe the summary? I got the summary down. Finding functions is easier. And sometimes you'll find out you'll need 1 or 2 integrals depending on which way you go. Okay, here's a new region I've defined, a cross-sectional area. Let's see if you can make sure we understand what we're talking about here. We got this area, y equal x. This is x equal to 4. And this area here is y equal to minus x. Okay, I'm going to rotate it around 4 different axes and see if we understand what we're doing here. My axis will be x equal to, here's the first one, x equal to minus 2. Okay, x equal to minus 2. What do I want? I want to use shells or washers. Shells or washers. Hopefully you see I want the easiest way to cut stuff is right here. Okay? Right there. That's this is parallel. My cut is parallel to the axis of rotation. So clearly that is a shell game. And I'll give you the answers here. I'll give you answers. You could stop the video and see if they're correct. I'll give you these kind of fast. This, well, maybe I'll give you this first one here. We're going to go what? I'll do the shells a little more slowly. What is that radius? Well, that's just x. This from here to here is x, right? Because this is x equal to 0. So this is going to be, the radius is x minus a minus 2, or plus 2, minus a minus 2. So it's 2 pi. What's the height of this shell? What's the height of that shell? Well, the height of that shell is just going to be the top curve, x minus a minus x. X minus a minus root x. Minus a minus, so that makes that whole thing a plus. And I'm going to integrate from 0 to 4. Okay? 0 to 4. That, okay, can you see that? That is the answer for what? That's the x equal to minus 2. What about x equal to 6? Well, let's put this guy over here, x equal to 6. Get rid of that. X equal to 6. It says, do I want to use washers or shells? Clearly, I really want the same kind of cut. It's, once again, it's a shell game. It's a shell game here. Now, though, we'll change colors. What is this radius? What's that? That's the radius of my shell, my cylindrical shell, right? What is that distance in red? What is that? It is 6, right? This is 6, is it not? And this is x. So it's just going to be the same thing. It's going to be 2 pi. Everything looks the same, 0 to 4. except my radius now is 6 minus x times x plus my shell height is the same, and this is now my answer for x equal to 6. All right. What about, it gets messier here. I'm going to have you find these answers, but when I do this, I'll give you these, I'll stop this thing, give you answers. You work this on your own. Let me see what we can do. Because I've done these on another video. Let's just drop this down a little bit here. Okay, those are those answers for the shell game. But when we're talking about y equal minus 4, let's put that down here. We got that. Now we're going down this axis. Y equal minus 4. Now what do I want to do? Well, clearly I want to keep my cut the same way. Now my cut, notice, is perpendicular. See? Perpendicular. This is a washer game. It's the washers. Okay, so what is going to be the answer? I'm going to write these down. Y equal to minus 4. Minus 4, the outside radius, and so you could stop and see if you get this right, but it's pi. I'm going to go from 0 to 4. The outside radius is going to be x plus 4. X plus 4 squared minus the inside radius is going to be minus root x plus 4 squared. Okay, minus root x plus 4, and that gets to be 4 minus 2. That's correct. Dx at y equal to 6. Y equal to 6, the radius is going to change. Oops. Y equal to 6. I'm still going to integrate from 0 to 4. I've got pi, but now my outside radius is going to be, it's going to be 6 plus root y, root x squared minus 6 minus x squared dx. Okay, so you can see I want to use the washer game here because making my cuts perpendicular, so whenever I had a y-axis of rotation, it just was easier. Now I could show you, I could use shells over here, I could use shells, I could use washers over here, but it's a much harder game. So let's make the problems as easy as we can, okay? And make sure you understand how we're doing this. If you understood this problem, you got all these things right, you're well on your way to understanding, you're visualizing well, and you're doing well. See you soon. Bye-bye.